is going to be Module 4 notes. Alright, and we're going to go over Module 4 notes. I'm sorry I'm missing class, but that's why I put these notes on a video for you. Okay, so for number 1, it says for the following right triangle, find side length x, round your answer to the nearest 100. Okay, alright, so for this problem, for a right triangle, we got to use what we call the Pythagorean Theorem. Okay, and the Pythagorean Theorem is a squared plus b squared equals c squared. Well, you got to know how to label your sides of a right triangle. So if we look at our right triangle here, okay, it's a right triangle because you have a right angle, and it's usually denoted by that little square in one of the corners. Okay, so if this is my right angle, the sides that are attached to that right angle are called the legs of that right triangle, which go into either A or B. Doesn't matter which one they put them into. But the side that is opposite or across from that right angle is called your hypotenuse, and hypotenuse goes into C. Okay, and so my sides x and 11 are my legs, so I set up x squared plus 11 squared, and side 16 is my hypotenuse, so I plug that into C, so it equals 16 squared. So if x squared plus 11 squared equals 16 squared, we go ahead and work out 11 squared to be 121, 16 squared to be 256, so I have x squared plus 121 equals 256. Get x squared by itself, so I subtract 121 from both sides, so my 121s cancel out, bring down your x squared. 256 minus 121 is 135, so I have x squared equals 135, but I do not want x squared, I want x, so I take the square root of x squared equals the square root of 135. The square root of x squared is x, and then the square root of 135, you can plug that into your calculator. You should get 11.62 when you round to the nearest 100. Okay, so knowing your sides and where to plug in is very key for solving right triangles. Alright, for number 2, simplify the square root of 9 over 49. I usually tell my students that you can break that up. You can rewrite it as the square root of 9 over the square root of 49. And of course, the square root of 9 is 3. The square root of 49 is 7. Alright, for number 3, evaluate the following. We have the square root of negative 100, okay, and the negative square root of 25. General rule of thumb, square root of negative 100 is not a real number, okay? And this is what I want you to use. When the negative is on the inside of the radical, the root cannot be even. And so this is my root. If there's no number there, it is understood to be 2, okay? So whenever my root is even, I cannot have a negative number under my radical, and so that is why this is not a real number. Now when that negative is on the outside of the radical, it doesn't matter because we just carry over that negative, and then you calculate the square root of 25 to be 5. So when the negative is on the outside of the radical, carry the negative over, calculate your radical. Okay? Now let's say for instance that we have the cube root of negative 8. Now I do have a negative on my radical, but when I check my root is odd, so I can calculate that. You can put that into your calculator and you would get negative 2. Alright. For number 4, we have simplify, and we want to simplify the square root of x to the 12th power. Okay? And so, with variables, one thing that you can do is you can rewrite this as a fractional exponent. Okay? Whatever your power is goes at the top, whatever your root is. Remember, if there's no number there, it's understood to be 2. So this is x to the 12 over 2. And we can work out 12 over 2, and that would be x to the 6th power. So my general rule of thumb here is whenever that power is divisible by that root, I can pull it straight out of that radical, and it would be x to the 6th power, because 12 divided by 2 is 6. Alright, look at number 5. You have the cube root of 8. You can plug that into your calculator. The cube root of 8 will equal 2. Because 2 to the 3rd power equals 8. Alright, for number 6, it says simplify. So we're going to simplify the square root of 4y to the 14th power. Now I can calculate the square root of 4, which comes out as 2. And then the square root of y to the 14th power. 14 is divisible by my root, which is 2. So 14 divided by 2 is 7. So y to the 14th comes out as y to the 7th power. So my final answer is 2y to the 7th power. For number 7, it wants us to simplify. So we have the cube root of 125 over 64. Alright, break that up. Cube root of 125 over the cube root of 64. Use your calculator. The cube root of 125 is 5. The cube root of 64 is 4. So my final answer is 5 over 4. Alright. For number 8, simplify again. Now we have the 4th root of 81u to the 28th power. Okay? So once again, I can break this up. The 4th root of 81 times the 4th root of u to the 28th. 4th root of 81, use your calculator, you should get 3. And then the 4th root of u to the 28th power, 28 is divisible by 4. 28 divided by 4 is 7. And so the 4th root of u to the 28 is u to the 7. And that's our final answer. Put that together, 3u to the 7th power. Alright, for number 9 and number 10, we have 256 to the 1/4 power. To evaluate that, you can use your calculator, and you're going to use this symbol here. So you would type in 256. Look for this symbol right here. It's usually, I call it carrot top. Okay, and then I would put in left parentheses, 1 divided by 4, close my parentheses. You should get 4. And then with 27 to the 1/3 power, use that symbol again. Punch in 27, use that caret symbol, left parentheses, 1 divided by 3, and you should get 3. Alright, same thing with number 10, 1/9 to the 3/2 power, break it up again. Break it up as 1 to the 3/2 power over 9 to the 3/2 power, 1 to the 3/2 power, 1 to any power is just 1. And then 9 to the 3/2 power, plug that into your calculator, same way we did the ones on number 9. And so 9 to the 3/2 power is 27. So your final answer is 1 over 27. Alright. Now the second part of number 10, you have 32 to the negative 4/5 power. Alright, whenever your exponent is negative, you always want to change that negative exponent to a positive exponent. So you always take the reciprocal of your base. Since my base is 32, the reciprocal of 32 is 1 over 32. And now that goes to the positive 4 over 5. And then I work it just like I did. 1 to the 4/5 power over 32 to the 4/5 power. 1 to the 4/5 power is 1. 32 to the 4/5 power is 16. So my final answer is 1 over 16. Okay? Next type of problem is where they want us to simplify a radical. Alright, so the first thing I need to do here is with the square root of 45. Now the square root of 45 is not a perfect square. So 45 is not a perfect square, but it has a factor that is a perfect square. Okay? So when I think about the factors of 45, I come to 9 times 5. 9 times 5 gives me 45. Alright? And one of my factors is a perfect square at 9. Alright, so I have the square root of 9 times 5. Break that up, that's the square root of 9 times the square root of 5. The square root of 9 becomes 3. And then the square root of 5 cannot be simplified any further, so I'll leave it as the square root of 5. And so, the square root of 45 simplifies to 3 square roots of 5. Start to put that together. They say they want you to simplify the square root of 27u to the 14th power. Okay? Now 27 is not a perfect square, but u to the 14th is, because 14 is divisible by my root, which is understood to be 2. Alright, so we have to break up 27. Is there a factor of 27 that's also perfect square? Well, I can break that up as 9 times 3. U to the 14th stays the same because 14 is divisible by 2. And so you start to pull out the parts that you can pull out. Now the 9 can come out because the square root of 9 becomes a 3. This 3 needs to stay. U to the 14th comes out because 14 divided by 2 is 7. So u to the 14th comes out as u to the 7. What's left on my radical is a 3. So my final answer is 3u to the 7, square root of 3. Alright. Number 13, simplify. Now they throw some variables at us. Okay? So we have the square root of w to the 13th power. Alright, now, with a variable, with an exponent, we can break that exponent up any kind of way we want, as long as their exponents add up to 13. So you got to ask yourself, what's the largest number in 13 that's divisible by a root, which is understood to be 2? Well, that would be 12. So I can break up w to the 13th as w to the 12th times w, which is also w to the first power. Now the part that will come out is w to the 12th power, because 12 divided by 2 is 6. So w to the 12th power comes out as w to the 6. What's left under my radical is just a w. And so my final answer is w to the 6, square root of w. Alright, if we look at number 14, simplify the square root of 54x to the 13th power. So now we're going to simplify with both a number and a variable involved. Okay? 54 is not a perfect square. Okay? But it has a factor that is, which is 9. So we can break up 54 as 9 times 6. X to the 13th is not a perfect square, but it has a factor that is. We can break up x to the 13th any kind of way we want. So we can break it up as x to the 12th times x. Now you go through and pull out the perfect squares. The square root of 9 comes out as a 3. The 6 needs to stay. The square root of x to the 12 comes out as x to the 6. This x needs to stay. So we can pull out a 3, we pull out x to the 6. What needs to stay up under the radical is a 6 and an x. And so my final answer is 3x to the 6th power, square root of 6x. Alright, now number 15, it says write the following in simplified radical form. Now we're dealing with a higher radical, a higher root. So it wants us to simplify the cube root of 32. So one thing I started doing is I would write my perfect cubes until I get a number that's bigger than what's up under my radical. So in this case, 32. So 1 to the 3rd power is 1. 2 to the 3rd power is 8. 3 to the third power is 27. 4 to the third power is 64. 64 is bigger than 32. And so I work my way backwards. Is 27 a factor of 32? No. Is 8 a factor of 32? Yes. And so I can break up the cube root of 32 as the cube root of 8 times 4. I know the perfect cube is 8. That will come out. So the cube root of 8 comes out as a 2. But the 4 needs to stay because it's not a perfect cube. And so my final answer is 2 cube roots of 4. So let's break up one that has both numbers and variables in it. Look at number 16. It says write the following expression in simplified radical form. So I'd have had the cube root of 40 t to the 8th w to the 3rd. Alright, so I already broke down some of my perfect cubes right here. So I know that 40 can be rewritten as 8 times 5. And 8 will come out. T to the 8th. 8 is not divisible by 3, but it has a factor that is. I can break up t to the 8 as t to the 6 times t to the 2nd power, because the t to the 6 will come out because 6 is divisible by the root, which is 3. W to the 3rd can stay the same because 3 is already divisible by 3. So now we go through, pull out what we can. The cube root of 8 comes out as 2. The 5 needs to stay. The cube root of t to the 6 comes out as t to the 2nd because 6 divided by 3 is 2. This t to the 2nd needs to stay. W to the 3rd comes out. 3 divided by 3 is w to the 1st power, or just w. And what needs to stay up under my radical is a 5 and t squared. So my final answer is 2 t to the 2nd power w cube root of 5 t squared. Alright, this is your first video for Module 4 notes. I will finish them up in the next video.